We'll look at the idea of navigation. So we've calibrated the compass. And what we've got here is the distance to the goal position, the GPS bearing to the goal position, and the bearing as read by the robot. So as the robot moves about left and right, you can see the bearing on the right hand side changes quite significantly. So the whole navigation algorithm takes the difference between these two numbers, where it wants to be and where it actually is, and that difference is used to drive the steering. So for example, if it's too far to the right of the cone, so it wants to be at a bearing of 324, but it's actually at a bearing of 355, then the difference taken there, which is about nearly 30, would go to the steering motor, so that difference would turn the steering wheels to the left. If it's too far to the left of where it needs to be, so it wants to be at a bearing of 323, but it's actually at 297, then that difference would drive the steering motor in the opposite direction. So you could say it's 0 when it's ahead, and it's to the right or to the left, depending on whether it's a positive or negative difference. So it will drive ahead when the difference is 0. So more or less about there. So the difference is, get it, about 300, so it should be going straight ahead at that point. And of course you can make it proportional. So if the difference is just a couple of degrees to the right, then it might just steer a couple of degrees to the left, and vice versa. So how much it steers can be proportional to the difference between where it wants to be bearing and where it actually is. So that can be proportional steering. And then this distance can be just used to drive the motor, drive the robot, or stop the robot. So it's 58 meters now. When it's approaching 0 meters, then you could say stop the vehicle.